Now we will analyze with Martin Beniston the current and expected variability of water in the mountains due to climate change. So we will return on the impacts of cryosphere degradation on our mountains. Martin?
Yes, hello, can you hear me?
Good morning, it's your time. Go ahead.
Thank you very much. I hope you can hear me okay.
Okay, the audio it's okay, and also the screen it's okay.
Okay, perfect. My apologies for not being with you in Italy today, but of course we are often faced with several major problems, and not just cryospheric problems since a year and a half. So today I'll talk about some results that emerged from a European project that I coordinated a few years ago. I think the results are maybe a little bit old, but I think the thinking behind the project and the conclusions that the project called ACQUA are still fairly valid today. So I'll just start. I think Tobias Molsch showed already a very similar picture at the start of his presentation, just to show that the European Alps are indeed, or can be considered as Europe's water tower. And this little red spot in the middle of the central Swiss Alps is a very important region because it supplies water directly or indirectly to several major river basins. And you see the number of people who are directly or indirectly using up this water in the Rhone Basin, the Rhine Basin, the Po in northern Italy, of course, and via the Inn River that flows into the Danube. You have about 80 million people who use up alpine water to some extent between the Alps and Central and Eastern Europe through to the Black Sea. So you can imagine that if any major and sustained change in climate occurs in this little red dot in the middle of the Alps, then this is going to have major impacts, not only on water resources in the Alps themselves, but of course, much further downstream. And I think Daniel Viviroli will be addressing the upstream downstream links later on in his talk. I'd just like to show you for the Rhone River, which was one of the focuses of the ACQUA project. This is the discharge curve during one of the reference periods of the 20th century, the 1960s to the 1990 period. And you see a sharp rise in discharge in the spring to early summer. And this is related to the melting of the winter snowpack in the Alps. And then as you go in further into the summer, to the warmer and possibly the drier part of the summer, where you still have a lot of water flowing into the rivers like the Rhone or the Rhine. And this is related to, at least partially, to summer glacier melt. So snow and ice are, of course, major components of the hydrological cycle, not only in the Alps, but in many other mid-latitude mountain regions of the world. So, of course, with a warming climate, the mountain cryosphere, winter snowpack and summer glaciers, and glaciers will probably be the elements of the mountain environments that will be the most sensitive to this global warming. And indeed, if we look at the recent climate record, we see that the warming that has occurred in the 20th century through to today is already disrupting the mountain cryosphere to a large extent. We have a sort of disproportionate warming observed in the Alps, up to 3 degrees in certain high mountain stations in the Alps compared to the global average warming of just over 1 degree. So something is taking place in the Alps and other mountain regions of the world with greater amounts of warming than the global average. And of course, this is having an impact on mountain snow and ice in terms of declining volumes of snow amount and the duration of the snow season. And these trends are likely to continue and probably even accelerate as global warming progresses in the course of this century. Now, during the ACQUA project, we had several groups looking at regional climate projections, focusing on the 2050 period, so the middle of this century. And this is work undertaken by Andreas Gobiet and co-workers. Andreas at the time was working at the University of Graz in Austria. And this is the upper graph is the wintertime average warming by 2050 compared to the reference period of the 1960s to the 1990s. So, and the lower graph here shows the summertime warming, June, July, August. So both graphs are showing changes in red and sometimes deep red, which means that by the middle of this century, in the summer, for example, in much of the Alps, we'll have warmed by an additional 2 degrees for a median carbon emission scenario. So this is not looking at the possible COP21 Paris Accord scenario. We're looking at a sort of higher emission scenario than what is suggested or encouraged by the Paris Climate Accord. So this is for temperature. If you look at precipitation, again, the upper graph is for wintertime and the lower graph is for summertime precipitation change. Well, many regional climate models suggest that we might have actually an increase in wintertime precipitation in many parts of the Alps. And on the contrary, in the summertime, we are likely to see declines in summertime precipitation. So this might actually have a consequence for snow amounts at very high elevations. We might actually see in the wintertime actually more snow falling, but at very high elevations, say beyond 3,500 meters or more, because of course we are looking at more precipitation possibly, but as we see on the left-hand graph, in a much warmer climate. So much of the additional precipitation below about 3,000, 3,500 meters is likely to fall out in the form of rain rather than in the form of snow. So we can also look at what glacier changes might occur. And this is a fairly old graph, but it's quite spectacular when you put it into animation. This is the change in a possible change in the Rhone Glacier from the start of this animation in before 2010 through to the end of this century. And this is work done by colleagues at ETH in Zurich and EPFL in Lausanne. And what you see, of course, is a very marked reduction in the ice amount. And what's left by the end of this century is just a small firn at the top of the mountains that surround the current Rhone Glacier Basin. So very marked, very spectacular changes, as one can expect, especially as we're looking at a median scenario, looking at a 3 to 4 degree warming world. So as I said before, much stronger warming than what is encouraged, what might be possible if one implements fully the Paris Climate Accord. Now, what would the changes in discharge look like with these changes in snow and ice related to the increases in temperature in all seasons and this seasonal difference in precipitation patterns? This is the discharge which we saw a little bit earlier, this time for the 1990s to 2010 period. And this is what it might look like for the last 2 decades before the middle of the century. And this is work undertaken by Paolo Borlando and his colleagues at ETH in Zurich. So what you see here is a slight increase in discharge in the wintertime months because of earlier snowmelt, but very strong decreases in discharge in most of the other months through the summer into the fall. And we can actually push the simulations even further, looking at the end of this century. This is from another study, which was a little bit beyond the objectives of the ACQUA project. But you see that, again, we have this sort of small increase in discharge in the wintertime months, but in all other seasons, we have anything up to 75 or 80% decreases in discharge in the Rhone River in the middle of the summer months compared to the reference period. And this is patterns that we also see in other rivers flowing off the Alpine domain, the Rhine River, the Po, and so on. So, of course, in 10 minutes, I don't have time to go into details of the impact, but just to give you an idea, we have this very strong climatic change taking place already today in the Alps, and which is likely to continue and even accelerate into the future. So impacting upon water resources. And the changes in water resources, and especially the declines of water availability in the summer months, as we saw in the two previous graphs, is likely to affect many water-dependent economic activities. Wintertime tourism, of course, agriculture, which in some parts of the Alps is irrigated. We have the energy sector, of course, hydropower, which is a major component of the energy supply in Alpine countries, Switzerland, Northern Italy, parts of France, parts of Austria. And you have other water-dependent sectors like industry. If we look to other countries, Chile was mentioned just in the previous talk, and the mining sector in Chile is one of the big users of water. So of course, in today's world, where at least in the Alps, there is still sufficient water to supply demand for these different sectors, this is not likely to be the case quite as comfortably in the future. So what is needed, of course, is to avoid conflicts of interest and economic conflict between these different sectors through improved water governance. In other words, we need to have local governments and supranational governments who actually are looking at how to supply equitable amounts of water to these different sectors so that none of them is losing competitivity, if you like, compared to the other sectors. So just the 2 or 3 key messages before I wrap up here. As we saw in previous graphs, the seasonality and quantity of water in Alpine rivers will be very different from what we have been used to in the past decades. Changing water resources is likely to have numerous impacts on socioeconomic sectors, which I mentioned in just the previous graph. Hydropower is, of course, one of the major sectors, but also agriculture, tourism, and industry. And new designs for water governance will be essential to ensure that all sectors who require water receive equitable amounts of water in the future. Okay, thank you very much for your attention.